Now the next example of a system of three equations that we're going to consider is one in which not all of the variables appear in each equation. Now usually in a case like this, it's going to be most convenient to use the substitution method to solve the system as opposed to elimination. Now as you scan the three equations here, which you'll notice I've labeled for easy reference and would recommend you do the same thing, it would be easiest to solve equation 1 for either x or y. If you use equations 2 or 3, solving for any of the variables there would definitely involve fractions. So I'm going to choose to solve equation 1 for y. So we'll have then y is equal to x minus 6. Now what I'm going to do is to substitute that value for y into equation 2. So we're going to have then 2 times the quantity x minus 6 plus 5z then is equal to 1. So simplifying, we'll have then 2x minus 12 plus 5z is equal to 1, or then 2x plus 5z then is equal to 13. And I'm going to label this new equation here equation 4. So now we have an equation with just x and z in it, and if we use that in conjunction with equation 3 above, we'll have a system of two equations with two unknowns that we then can proceed to solve fairly easily. So I'm going to rewrite those two equations next to each other, and we'll go from here. Now you can see that what I've done is to rewrite equation 3 here underneath equation 4. And now what we have then is a system of two equations and two unknowns that we can easily solve. And in this case, using elimination I think will be easiest. So I'm going to choose to eliminate the x variables. I'm going to do that by multiplying equation 4 by 3 and equation 3 by negative 2. And you can see the results here in blue. That will end up then with 6x plus 15z is equal to 39, and negative 6x plus 8z is equal to negative 16. And if we add the two equations, we'll end up then with 23z is equal to 23, or z then is equal to 1. So now we'll next tackle finding the values for x and y. Now we just found the value of z to be 1, so we can next then use either equations 3 or 4 to find the value for x. And I'm going to choose to use equation 3. So what we'll do then is simply substitute then in the value of 1 for z and solve the equation for x. We have then 3x minus 4 is equal to 8. 3x is equal to 12, or then x then is equal to 4. And to finish up, to find the value for y, I think we can use the variation of equation 1 that we started off with initially, where you remember we solved for y. So y was equal to x minus 6. So y then will be equal to 4 minus 6. So y then will be equal to negative 2. So to finish up then, what we'll do is express the solution as an ordered triple. Again, being alert to putting the values in alphabetical order. So the value for x we found to be 4. The value for y was negative 2. And the value for z is positive 1. Now it's pretty straightforward in this case, but would really encourage you to check all three values there in all three equations to be sure that they check.